Using percents. Sometimes we need to find the percent of a number to help us solve a problem. That percent becomes a part of a total ratio. There are many ways to find that part of a ratio given the percent and the total. When the total is 100, it is very easy to solve. So, for example, what is 46% of 100? Since a percent itself is out of a total of 100, we can just look at what the percent is. So in this case, it was 46% of 100. So that 46, the percent, is our part out of 100. So that 46% of 100 would be 46. Again, it's the number in the percent itself. But what if the whole total is not out of 100? The total can be out of anything. It's not always going to be out of 100. So it's not going to be as easy as just looking at what the number in the percent is. We're going to have to do more work. For example, what if you wanted to find 30% of 50? The total is no longer 100. We now have a total of 50. So think about how you can figure that out. We're not going to be able to say 30 anymore. The answer is not 30 because the total is not out of 100. It's not just going to be the percent you see. But how can you relate that total of 50 to the total of 100? The relationship of that old total to the new total can help us find what that new part would be. Also think about what we know about percents that we can apply to this new situation, what patterns we can use, what relationships percents have to parts and totals, and maybe what are some problems we might now have to think about, again, because the total is different. So let's look at some strategies we can use. The first will be using the fact that a percent is a total out of 100, so we can turn that into a fraction. So we have our same example here where we're still trying to find 30% of 50. So the first thing we're going to do is take that 30% and turn it into a fraction over 100. 30% would equal the fraction 30 over 100. We'll then create a proportion with the fraction and the total number. So our total was again 50. So we know the information that the 30% should be something, some unknown amount, some part over that denominator of the total, which is 50. So 30% equals something over 50. So again, we're rewriting 30% as 30 over 100. Equals something over 50. So now we need to see the relationship and figure out the relationship between the denominators, since we have both of our denominators. We have the 100 and the 50. So we can then do that relationship to the numerators. So the relationship here, how are we getting from 100 to 50, is we're dividing by 2. So since we divided 100, that denominator, by 2 to get 50, we can do that to the numerator. We can divide the numerator of 30 by 2 to get 15. So 30 divided by 2 is 15, so that's our unknown amount. That's what the question mark is representing. So 15 over 50 equals 30 over 100. That's solving for that value. So since 15 over 50 equals 30 over 100, we now know that 30% of 50 is 15. We can also look at this more visually using a tape diagram. So here we have our 100% is broken out of the new total of 50. So we're looking at our tape diagram and see we have our total on the top is 50, which is relating to each percent on the bottom. And because we only want 30%, that's why we're only looking at the first 3 parts of the tape diagram. We're only shading those 3 parts because we only want 30%. And we can see that the 15 matches up with the 30%. So this model supports that 30% of 50 is 15. Let's look at 2 other examples as well, just to get the hang of the process and figuring out how you would, again, find a percent of a number that doesn't have a total of 100. It has a different total. We're trying to find the part of that total. In the first example, we have what is 15% of 20. So instead of looking at a tape diagram visually, I'm going to use where we're breaking down first the fraction as whatever the percent is over 100. So for the first one, we have 15%, so I can write that as a fraction 15 over 100. We're then going to set that equal to some unknown number, the part, over the new total of 20. We can then solve this and solve for that unknown by looking at the relationship of the denominators and doing that same relationship to the numerators. From 100 to 20, we have a relationship that is dividing by 5. So I want to divide the numerator by 5, so it has that same relationship when I go from 15 to some unknown number. Well, if I divide 15 by 5, that unknown number would be 3. So it looks like 15 over 100 is equal to 3 over 20. So 15% of 20 is equal to 3. Let's do the same process for this second example. We have what is 32% of 25. So again, we'll first take that percent of 32 and write it over 100. 32 over 100. So now we need to set that equal to have our new total of 25 in the denominator, and we have some unknown part in the numerator. That's what we're trying to figure out. Now we'll solve for that unknown part by looking at the relationship of the denominators. 100 to 25 is dividing by 4. So we'll do that to the numerator. We'll divide 32 by 4, which gives us an unknown value of 8. So 32 over 100 equals 8 over 25. So 32% of 25 is 8. And we can check our answers. Again, 15% of 20 is 3, and 32% of 25 is 8. So again, we're using the method of rewriting the percent as a fraction over 100 and then setting it equal to some unknown amount over a new total that's given.